Morning.
Last time I talked about precision and recall as measures to seeing how a classification model is working, if it's doing what it's supposed to do. In contrast to accuracy and other measuring criteria, these two would give you a more elaborate view on how your classification model is working. But besides this time I'm going to talk about F1 score. So the F1 score is like the harmonic mean. So you can have an arithmetic mean and a geometric mean, but the harmonic mean gives you a sort of balance between the precision and the recall. So if, say, we looked at the sort of overlap within the precision and recall, that having a classification model, like if it was classifying, I'm going to use cats and dogs for this session. If it was classifying cats and dogs and you had like 99 dogs and 1 cat, and it classified everything as dogs, we are ignoring the 1 cat that exists. Yeah? So we need to find a sort of balance. Precision and recall work hand in hand. If one is higher, the other is lower. So the F1 score sort of finds a balance between the two, which I will show you. So there is the arithmetic mean would be half precision plus recall. The geometric mean would be precision times recall to the power a half. But this time we're interested in the harmonic mean. So the F1 score is equal to 2 times precision times recall out of precision plus recall. Hope that makes sense. If you remember precision from last time, precision was if we're trying to classify an object, say cats and dogs still, if we're trying to classify, our model is trying to find out which ones are cats. The precision will be, among those we classified as cats, which ones were actually cats, the true positive, out of the ones that were cats and classified among cats, plus the false positive, which I'm going to show you. I'm going to draw down an example. The true positive plus false positive is basically a total of how many were classified in the cat class, whether they were cats or not cats. Draw down an example. As with the arithmetic mean and geometric mean, as just showing the other ways in which we would sort of try to find a balance between the precision and recall, but the F1 score works better. So I'll show you already written down example. Do you remember the confusion matrix? I talked about it. I'm going to draw down a confusion matrix. So we have cats and dogs. So how many were classified as cats but are not actually cats? Then how many were classified and are cats? Yeah? So if our classification model said 2 were cats but they were actually dogs, yeah? Then it identified 9 cats that were actually cats. It identified 7 dogs that were actually dogs and said 4 were dogs but they were cats. So if we are finding classification for cats, these are our positives. So this becomes the true positive because we're trying to identify cats. And these were truly cats and they were identified as cats. Yeah? So it's a true positive. This becomes a false positive. We're looking for cats, but these were wrongly classified. This then becomes a true negative and a false negative. So we say precision is equal to true positive out of
those 4 that the 4 are these cats or these dogs?
are cats. They were classified as dogs, but they're actually cats. So the ones here are cats. This shows what they were classified as. Yeah? True, positive, yes. Yeah.
No, I said true positive plus false positive.
Oh, yes. So what is our true positive? 9 out of 9 plus 2. So among everything that was classified as a cat, that's where we pick our precision from. So how many positives, true positives, is our model classifying as true positives? It's basically what precision is trying to tell you. So 9 out of 13. This is 11.
Yeah.
9 out of 11 times 100. Should give you like an 81%. Is that right? You could get that when I get you the recall. 82. 82%. So recall true positive out of true positive plus false negative. This is 9 out of 9 plus 4. What does this one give you? 69? %. So this is our F1 score. So 2 times our precision is 82% times recall, which is 69% out of 82 plus 69. What are we getting there? Should be 70 something.
74.74.
So roughly 75%. So F1 score is not necessarily better than precision and recall, but it finds a balance between the two. So if one is lower than the other, if we used only precision, we get 82% and say, oh, that looks good. If we only got recall, and so 69% would be like, our model is not doing so great. So with F1 score, if one of them is low, it will show the low. If one of them is higher than the other, we still get a small hike. So it's a sort of balance. It's not necessarily better, but we're trying to judge our model of a certain sort of metric, yeah? And try to see if it is averagely good, not good, or bad. We already saw that accuracy does not work. It's not enough to judge our model. And my time's up. That's what I'll cover for today. Thank you.